Yes. Yeah. Good evening, all. So, in the last class, I was discussing about this PySpark introduction. What is Apache Spark? Why PySpark? Need for PySpark, PySpark, Python, and Scala. Real life usage of PySpark, PySpark job market, right? Yes. So, yes. So, first, evolution of Spark, evolution of Apache Spark. Spark was developed. Spark was developed by Matai Zaharia in AMP lab. In AMP lab. In AM, okay. Spark was developed by Matai Zaharia in AMP lab, Berkeley. In the year 2009. Spark was open sourced. In the year 2010. Spark was developed by Matai Zaharia in the year 2009, and it was open sourced in the year 2010. And Spark was donated to, right? Spark was donated to Apache Software Foundation. Spark was donated to, yes, Apache Software Foundation. In the year 2000, in the year 2013. Okay. Okay. I'll defining Spark. Hmm. I define Spark in 4 lines. What I define Spark in 4 lines. Spark is a open source. It is an open source cluster computing framework. Cluster computing framework, right? It is an open source cluster computing framework with distributed execution, right? With distributed execution, right? In parallel process type, right? in parallel processes type, right? With in-memory computing feature, right? With in-memory computing feature. Used for large-scale data processing, used for large-scale data processing. So it is an open source cluster computing framework with distributed execution in parallel processor style with in-memory computing feature and used for large-scale data processing. The main feature of Spark in-memory computation, which you are not going to see in Hadoop, right? So here in Spark, everything in-memory computation, storage and processing happening at the RAM level. So what is in-memory computation, right? In-memory computation. Here, data gets loaded into RAM. Data gets loaded. Data gets loaded into RAM, right? And data gets processed. Data gets processed within the RAM. Data gets loaded into RAM and data gets processed within the RAM. Here data gets divided into partitions. Data gets divided. Here data gets divided into partitions. And the partitions are distributed. And the partitions are distributed.
One question.
Yes.
Usually the data is loaded into the hard disk, right? C or D drive.
Mm.
How can this data is loaded into RAM? Is there any separate commands for that, or how can we check that?
Okay, yes. So that's what I'm discussing. Here data gets divided into partitions. Generally in Spark, right? Data gets divided into partitions and the partitions are distributed across multiple RAMs of multiple slave nodes of multiple, right, worker nodes. And are processed parallelly. Okay, 1 second. We got resilient, right? This data gets loaded into RAM. Data gets plotted within the. Okay. Now observe this. Observe this diagram, right? Yes. This is your data. Data gets loaded into partitions. Data divided into partitions. So P1 partition, P2 partition, P3 partition, P4 partition. This partition stored in RAM 1 of slave. slave 1, slave 1, slave 2, slave 3, slave n, right? Yes. Okay. So the data is divided automatically, right? That data divided into partitions. So we need to will be specific. We can control this parallel processing in the case of Spark. In the Hadoop, we cannot control that parallel processing. But here in Spark, we can control, we can specify how many partitions depending upon that data gets divided into those many partitions, loads across those many RAMs, right? Available across the multiple worker nodes. So here data, okay. I'll just show you how this computation is going to happen. How this computation is going to happen within this Spark. Okay. But here in-memory computation means it is not like a disk level storage. In Hadoop, the disk level storage, and that's why, right? Here Spark is 100 times faster than Hadoop MR. Spark is faster than this Hadoop MapReduce, right? Yes. Because of this RAM level storage and processing. Data gets divided into partitions, and the partitions are distributed across multiple RAMs of multiple worker nodes and are processed parallelly, right? Yes. Right.
Vijay, one quick question. What is the meaning of resilience?
Okay. See, Spark has got the capability, right? Spark, where you have seen the word resilient here? Resilience distributed data sets, we say. Resilient
RDDs.
distributed data sets, we say, RDDs, right? See, Spark has got the capability of regenerating the lost partitions data. Spark has got the capability of regenerating the lost partitions. Means when you are running this Spark data on multiple worker nodes of multiple RAMs, right? Suddenly, if any system goes down, it has got the capability of regenerating the lost partitions by itself, right? And that is one. And secondly, right?
Sagar,
Whenever, one second, whenever, okay, observe this in Spark, just you'll get a total full idea about this computation, Spark computation. So just observe. So in Spark, Spark data objects we called as RTDs, resilient distributed data sets. Okay, Spark data objects we call as RTDs, resilient distributed data sets. Okay, see the observe the resilient distributed data sets. Okay, the first data, this is a data object. This data object is divided automatically. It is divided into multiple partitions. These multiple partitions are stored across multiple RAMs of multiple worker nodes and processed. The output of this will be the input to the next one, R2. The output of this will be the input to the next one, R3. R3 output will be the input to the next one, that is R4. Now, first R1 loads in the RAMs. R1 loads into the RAMs. All the partitions of this R1 gets loaded into RAMs and gets computed. Loads and computed. But R1 output is taken by R2. See, R1 size is 2 TB. R2 2 TB. I was just think like 20 GB. Each one is of 20 GB. Each one is of 20 GB. Each one is of 20 GB. What is your observation here? Do you think all the RTDs will be stored in the RAM? Hello?
No.
All the RTDs are going to be stored in the RAM? I said everything getting stored in the RAM, everything getting processed in the RAM. So do you think all these 4 RTDs or 40 RTDs? Assume if the data flow is too large.
Hmm.
If the data flow is too large, do you think all the RTDs are stored in the RAM?
Yes. In that case.
If all the RTDs, each RTD, each one is a bigger data volume. Each one is a bigger data volume. Even storing one is also a bigger task, right?
Yes.
Storing one, it's a bigger task in the RAM. But storing these many RTDs, right? It's a bigger task, right? For example, each one a bigger, but storing this 4 or 40, it cannot accommodate. They can't be accommodated in the RAM. All the RTDs at a time you cannot. At a time you can't accommodate all the RTDs at the RAM. One by one only it can accommodate. One by one only it can accommodate and it can store and process. If all are accommodated at a time, that much of RAM capacity can't be maintained. And each one is a bigger data volume, right? So what happens here? That is what resilient distributed data sets. So here R1 loaded computed. Now R1 loaded, the output of R1 taken by R2. Now R2 partitions gets loaded. R2 partitions gets loaded and computed. R2 the loaded, computed. When R2 loading and computing is finished, R1 gets removed from the RAM. R1 gets removed from the RAM. R1 and its partitions, everything automatically they are going to get removed from the RAM.
Yeah. Understood. Okay.
Now, okay, next R2 output. Now R2 output is collected by R3 as input. When R3 loads, R3 loaded and computed. When R3 is ready, the total R2 is going to get removed from the RAM. It is not required because its output is collected by R3. Now R3 partitions stored or distributed across RAMs of multiple worker nodes, processed parallelly now. Now you got the output of it. That output is taken by R4. That R4 gets loaded and computed. Now when this is ready, loaded, computed, and it's ready, right? Then this entire R3 gets removed from the RAM. It's not required, right? Already that output is collected. Yes. Now finally, this R4 output is collected by the client. This output is collected, right? Once this output is collected, the final output, this is our final output, what we are expecting. And this R4 is also going to get removed from the R4 also gets removed from the RAM. The output you got. Now what is there in the RAM? Now what is present within the RAM?
Only output.
RAM is empty. No RTD in the RAM. All the RTDs loaded one by one. They got computed one by one. You got the final output, whatever you want. No RTD in the RAM now. No data, nothing is there in the RAM. You can trigger the next workflow. You can trigger the next data flow. Right? The next data flow also one by one gets loaded, one by one gets computed. And once after that, nothing will be within the RAM. This is what I'm going to discuss, that resilient distributed data sets. We say resilient, right? And during this, here, this entire thing, now try to say, I clearly said parallel processing. Parallel processing is going to happen, right? If parallel processing happening, Okay, try to answer. R1, R2, R3, R4 are executed parallelly.
No, sequentially it is happening.
Are they executed parallelly?
No.
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 Parallel execution, very high speed distributed execution, I was saying, right? So here, why please be in mute? Yes. Here, until R1 output, until you get R1 output, R2 cannot execute or not.
Yeah.
Until R1 output you get, R2 can't be computed. Until R2, once R2 gets computed, once the output you get, then only R3 can compute by taking its output as input, right?
Yeah.
All the four RTDs, if you are executing, R2 cannot get its input. R2 cannot get its input because still R1 not computed. Until R1 computed, execution finished, R2 cannot get its input. Similarly for R3 and R4. One after the other, they has to execute, right? Observe carefully here. In R1, I got some 10 lakh records. Assume you have got some 10 lakh. On that 10 lakh records, you're applying a transformation. Do you think from R1 to R4, the size and the records are going to be the same, or it is going to vary?
Going
From
to vary.
R1 to R4, or that they are going to vary, right?
Yes.
They are not going to have the same number of records. They are not going to have the same data values.
Yeah.
R1 has got 10 lakhs. Immediately on R1 data object, on this 10 lakh records, I'll perform filter operation. I'm going to perform some filter operation. Filter only the records belongs to a particular city, Hyderabad. Means, okay, you got the output of what? Of city Hyderabad. Records, all the records of city Hyderabad. Out of 10 lakh records, the Hyderabad city records are 2 lakhs. Otherwise, assume 5 lakhs. 50% of the data eliminated or not? Hello?
Yes. Correct.
50% of the data eliminated. That is the output. That output is nothing but R2.
Hmm.
That output is nothing but that R2 input. In that R2 input, in that R2, my business logic implementation, I doesn't want even the entire Hyderabad records also, I doesn't require. Okay, in that particular, I am dealing with, I want my task is only on a particular department of Hyderabad. Marketing department, sales department, accounts department, multiple departments are there. In that, I want to just process the data of a particular department, like sales department. In that, again, if you filter, right, again, you perform some kind of filter operation from this 5 lakh, the output you get as 1 lakh. That output is taken by R3. Again, on R3, if you perform any kind of transformations, right, map transformations, or merging, or sorting, or grouping, any kind of transformation on R3, if you apply, you will get R4. R3, try to add, give increment to all the employees of sales department. Sales departments, how many? 1 lakh people. To all that 1 lakh people of the sales, add 10,000, right, as the increment, right? Yes. 10,000 added. Means R3 output will be the salaries of that employees with, which are incremented by with 10. Means some kind of mapping operation. Mapping operation is done. What mapping? Add in each element of transformation. What we call each element of transformation. What do we mean by map transformation? Means whatever transformation you are applying is going to be applied on each and every element, each and every employee salary, right? It is. So you are getting that from the R4 you got. From the R4, again you performed any kind of some different transformation you apply, you will get on. Means all the RTDs The number of records won't be same, that they don't have the same data value, they don't have the same number of records. The one will be the output to the next. The output of one will be the input to the next. The output of one will be the input to the next. So they are executed RTD by RTD, one by one in sequential, right? Means one after the. That's why first R1 and its partitions, everything gets loaded, computed, processed. Then R2, R3, R4. Once the entire computation is finished, nothing is present within the RAM. Nothing in the RAM, right? The RAM is free. Again, whenever you trigger the next flow. Yesterday I was discussing Spark is lazy evaluated. Lazy evaluated, right? Lazy evaluated means if you are performing some kind of action on this R4, if you are performing some kind of action on this, so that entire flow executes from R1 to R4. The entire flow executes from R1 to R4. If you are performing some action on R3, the entire flow executes from R1 to R3 and R3 output will be collected. So performing action on R4, then the flow executes from R1 to R4 and this R4 output will be collected. If you are performing action on R2, then from flow executes from R1 to R2 and R2 output will be which one output you want, which output you want. You have defined the entire flow, which output R2, then R2 dot action, R3, R3 dot action. If you want R4, R4 dot action. Means from R1 to R4. If you want to compute R4, R4 dot action means I want R4 output directly. R4 can't be executed, right? I want R4 output. R4 dot action we say immediately only this R4 can't be executed. You cannot load only that R4 partitions into the RAM and gets executed, right?
Yeah.
From where it has to get the input.
R3
R3.
output.
R3 also you cannot load and compute. It has to get the input from R2. Who has to give the input to R3? R2.
R2 output.
Again R1 means if you want to compute this R4 and R4 output to be collected, you need to say one by one. You need to load, compute, get the output, again take as input to the next. Now after executing all this R1 to R3, that output will be taken by R4. Now R4 loads, computes and gives the output. That is what? Lazy evolution. Lazy evolution means on demand executing the flow. On demand executing the flow, right? See, what is active evolution? R1, R2, R3. Immediately when R1 is executed, when R2 executed, when R3 defined, immediately executed. Whenever R4 defined, executed. That is what? Active evolution. Whenever they are defined, immediately executing. That is what active. But here, even though they are defined, it won't be executed until you make some action. On which one you make action? From the starting to that point, it is going to get executed. Right? R1, R2, R3, R4. So whenever you say R4, on that R4, if you perform an action, right? Yes. On which one you are going to perform action? From the root, this we call it as root 1, root RTD. And this was the current RTD, right? From the root RTD to current RTD, they are going to get executed and gives the output. So all the RTDs, all the Spark RTDs means Spark data objects. All the Spark data objects can't be loaded at a time, one after the other. Then you may ask, you may get a query immediately. Where is parallel processing here? Where is parallel processing here?
Partitioning. Loading into the data.
Where is parallel processing? I said, if I was defining, right? With the parallel processor style, with the distributed execution, with parallel process style. Then where is this parallel processing means? R1. This R1 divided into 20 partitions. P1, P2, P3, P20. This 20 partitions stored at 20 RAMs, R1, R2, R3, R4, R5, into of 20 worker nodes, slave nodes. All these partitions are executed parallelly. All these 20 partitions executed parallelly by 20 systems. Or if you got 40 partitions are distributed across 40 worker nodes, means into the 40 RAMs of the 40 worker nodes, and are executed parallelly. Here you can see the parallel processing. Once this processing is finished, that output is collected as input to the next R2. Right? Yes.
And
Understood.
Vijay, and here R2, right? From R2 onwards, again the above same 20 systems we use are those are the different systems.
Forget about 20 system. I got
Again,
one.
R1, R1
Forget
systems.
forget about 20 system. Assume I got only one system. Then
We have to use the same
so
one system.
we got single node cluster, multi node cluster.
Hmm.
Single node cluster, everything happens single, right? Work multiple. Okay. What happens? Your query is what? Now
My
will
query-
you use the same slave again? You are talking by the R2.
Yes, correct.
Okay. It will use.
It will use
Assume you got a 10 node cluster. All that first R1 divided into 10 partitions stored across
all 10 nodes.
10 nodes and processed parallelly. Their output is collected by R2. And R2 also gets distributed across 10 slave nodes.
Same
Parallel
10 slave
processing
nodes.
is
Yes.
10 place.
Huh.
But you got 20 partitions. R1 divided into 20 partitions, but you got only 10 slaves. Then
Cannot be happen.
huh?
That cannot be happen, right?
20 partitions into 10 slaves means each slave storing two partitions.
Yeah, two files.
Two partitions, yeah.
Two partitions. Forget, you just forget about this 10 systems, 20 system. One system is there.
Okay.
All the 20 partitions into the single system, right?
Yes,
Yes.
that is possible.
First partition 1 executed, next partition 2, next partition 2. Here you won't see the parallel processing. See, 10 forget about all this. A labor example. For a building construction, you brought some labor slaves. You got 10 tasks, 10 labors.
Yes.
You'll get high speed because none of the task is in the waiting state. But you brought some you brought some less labor. Today you didn't get that labors, more labors. Only 10 labors you got. But lot of tasks, 20 tasks are there. 20 tasks you are trying to assign to 10 labor.
Yeah, 10 will be always on.
Means the 10 tasks executed by 10 labors, first they are assigned. Up to afternoon they work on that first task. Later they'll be assigned the second tasks. After post noon. Means 10 tasks are in the waiting state, right?
Yes.
For nearly like up to 4 hours, some 4 tasks are in the waiting state. Only 10 tasks are executed, 10 tasks are in the waiting state.
Correct.
Means total time taken 8 hours. For the first task, 4 hours taken. Again, remaining 10 tasks, if we are assigned to the 10, again, they means 8 hours. But if you have brought 20 labors, right, only within that less
4 hours.
That within 4 hours it has been come. It is also the same thing, right?
Yeah.
So if that you have got more worker nodes, more speed you are going to achieve. If you have got only 5 worker nodes, 20 partitions, four partitions in one, right? So speed will decrease. Same thing. If you have got only one, there's no one by one. Only one labor performing all the 20 tasks. One person executing all the 20 tasks. 5 days it takes.
Yeah.
Okay. So that's what, right? So here, any number of whatever might be the partitions, they are going to get distributed across the available slaves and are getting executed parallelly. We no need to perform anything here. We don't need to do anything, right? Any kind of algorithm is not, it's not automatically. The Spark execution model is going to take care. But if you want, you can increase the partition. Increasing the partitions is possible in the case of Spark. I want more parallel processing. Assume your data object divided into 20 partitions, but my available slaves are 40. Available slaves are 40.
Yeah.
Means you got only 20 tasks, but you got 40 labors. You are assigning the 20 tasks to 20 labors, but 20 labors are sitting ideally.
Hmm.
Understanding? More
Yeah.
slaves available, more workers available, but you have assigned only to 20, remaining 20 are idle. Then what you can do? In Spark, there is a path, you can control the parallel process. You can increase the parallel processing. The 20, you can make it into 40 and assign to 40.
Hmm.
The 20, make it into 40 tasks
Yes.
and assign to 40. That we will be specifying it. Whenever we are loading the data itself, very simple, right? Whenever we are loading data itself, we can provide the number of partitions we require, right? Yes. It will be divided into those many partitions. Those partitions distributed and are processed parallelly, right?
Yes.
Lot of understanding, right? Lot of understanding required here in this Spark computation model. It's totally as compared with that Hadoop execution model. This is totally different. In Hadoop, what is the execution model followed?
Lazy
No,
evaluation.
no. This is lazy
Distributed.
evolution. Execution model is map reduce
Distributed.
execution
Map
model. Map reduce execution model. Mapper reducer is there, right?
Yeah. Yeah.
First mapper phase executes reducer. Internally, everything is converted into that MR execution model. In Scoop or in Hive or everywhere, right? In Hadoop, map reduce execution model, right? But here, I'll discuss what is the drawbacks with the map reduce execution model. What is the advantage of Spark execution model, right? So this is mainly as you have asked, right?
Yeah.
How this Spark computation. Later, I discuss in brief, right? How this computation in Spark. One is a lazy evolution.
Hmm.
For example, there is one more. R1 is there. R2. If you got any queries, everyone, you can unmute yourself and you can ask your queries, right? This is how this processing is happening in Spark. Now, R4 is executing. R4 is executing now. Still totally not executed. R4 still not executed totally. Is R3 available in the RAM?
No.
Until I said until this R4 execution completed. Once this is execution completed, then R3 removed. Hello?
Yes.
Once R4 fully executed and it's done, right?
Yes.
R3 gets removed. See, when R2 execution finished and R2 is totally, then R1 and its partition will be removed. When R3 total execution, when R3 total execution
Hmm.
finished, then R2 and its partitions, everything will be removed, right?
Yeah.
Now here have got a bigger data flow. Now currently R4 is executing. R3 available or not? Still
Available.
Yes.
available. Available. R2, what about R2?
R2 is
Not available.
not available.
See, yesterday I was discussing one more feature. Persistence. Persistence.
Hmm.
Can you remember, right? Yes, 1 second. And this
Yeah. Replication. It's kind of.
persistence, as I was saying, right? In-memory computation is one. You understood, right? What is in-memory? Lazy evolution is, right? What you understood, lot on demand executing the data flow. Until then, it won't execute.
Yeah.
Persistence means re-executing the results is one more important feature of PySpark. Reusing the results of already executed transformation. Reusing the results of already executed. In Hadoop, it cannot. In Hadoop, you cannot. In map, not only not in any other, in other things, you cannot. Here you can. For example, persistence feature. Reusing the results of already executed transformation is possible. Here, R4 executing. R2 available or not?
Not available.
Not available. Everyone try to respond. R2 not available. what R3 is taking input from whom?
R2.
R3 is taking input from which one?
R2.
R2, right? R2 output is the input to R3. R3 output will be as input to R4. Already R2 executed. R2 output results taken by R3. Its output is taken as input by R3. That's fine. See, it doesn't. R5 input is what? R5
R4
input is what? R2.
R4
Assume this output is taken as input by R5. In this way, assume tomorrow there is one. Tomorrow you got R5 task. Tomorrow you got a new task R5. You got a R5 task, but what is that? It has to take the output of which one means R2 output. Okay. By the time R5, R4 computation is finished, R2 got removed, right? Tomorrow I got some R7. R7 also taking output, needs the output of R2 as the input. Tomorrow some R9, right? R9 also wants this R2 output as input to it. Multiple flows are there. Multiple data flows are there. They are expecting the output of a particular RTD. Assume. But by the time R4 execution finished, okay. If multiple flows wants the output of a particular RTD, but once this R3, R4 computation finished, R2 this is not available now. This is not available now. So entire flow. So for example, to make it clear, right? To make it clear, just see this data flow. Observe this data flow. R1, R2, R3, R4, R1, R2, R3, R4, R4, R5, R6. From R4, R7, R8. From R4, R9, R10. Observe this flow. This one is the flow 1. R8 output collecting. Flow 1. Flow 2 is this. 1, 2. In this way it is going. In this way it is going. Right? Next. In this way, like flow 3. Flow 1, flow 2, flow 3. Flow 1, flow 2, and flow 3. 3 flows. Flow 1, R1, flow 1, you talk about the flow 1. R1, R2, R3, R4, R7, R8. R1, R2, R3, R4, R7, R8.
R8.
This output I want. Means you need to perform action on this R8. Then the flow executes from R1 to R8. Once one by one loaded, once this is ready, R2 is completed, R1 gets removed. When R3 is ready, R2 gets removed. R4 is ready, R3 gets removed. When R7 ready, this gets removed. When this is ready, this gets removed, right? Once this output, right, this also gets removed. Output, this output is collected and that also gets removed. That's fine. Flow to you see. Now try to say what is the flow
Yeah,
to R1, R2, R3,
R3, R4, R5, R6.
R6. Here also the same thing, right? When this is ready, this gets removed. When this is ready, and complete this gets removed. When this is ready, this gets removed. When this is ready, this gets removed. When this is ready, this gets removed. Flow 3, R1,
R1, R2, R3, R4,
R3,
R9,
R4,
R10,
R9, R10.
R10.
When this is ready, this gets removed. When this ready, this gets removed from the. When this is ready, this gets removed. When this is ready, it is going to get removed. And finally, this output is collected. This output is collected. This also gets removed. All the three flows executed, all the three flow output you got, you collected it. Now, what is there in the RAM?
Output of all the three.
All three flows output.
Okay, no, there's no RTD in the RAM. There is no RTD in the RAM. All the three flows got executed. What is the drawback you are observing here?
Mm,
It's a lazy evaluation.
See, for example, there is some unstructured data is there. There is some unstructured data. A simple task. R8 is calculating the total cell. R6 is calculating the max cell. R10 is sum min cell. Total cell, max cell, min cell. For all this tasks to perform, first salary has to be, you need to extract the salary, right? You are supposed to, that
yes.
is what R4, that is R4 is what? Extracting the salary. From unstructured data, think that from R1, you made some steps, you got some steps you did. Either you perform some splitting operation or some different, whatever the transformations you do, all that. Finally, you extracted salary. Up to here, the first four steps are for what? Extracting the salary from a particular unstructured data. That is fine. After that, extracting the salary, you did total salary, max salary, min salary. Okay, the first one, total salary, you did. Total salary, you did. You got the output, right? Some 90 lakhs, assume. But when to performing the second flow execution, why are you coming from that first step again? Why are you re-executing the flow?
Mm,
Already you got the salary. Directly take the salary and perform max salary.
correct.
Why are you executing again the first four flows again? Directly R4 output, you take it and execute.
Yes.
R4 output, you take it and execute. But once the first flow execution is completed, do you see any RTD? Anything is available? If R4 available, after the entire flow one execution completed, if R4, if it is available in the RAM, I can take R4 output and I can compute. But nothing is available, right?
Yeah.
So if I want to get the R6 output, compulsory, I need to start from R1. If R4, if it has available, right, in the RAM, then R4 output I should have taken in and I should have executed, right?
Yes.
Understanding. So what is the problem here? Every time the flow is executing, it's re-executing from the beginning. Think that here to extract the salary, 4 steps, but assume that some 20 steps involved in extracting the salary. Means every time you are executing the 20 steps, right, for extracting the salary again and again.
Yes.
Yes.
Reduce it. We have got an option in Spark. already executed transformation results can be reused. You can reuse again, no need to re-execute again, right? There is a concept R4 you persist it. R4 you persist it. What is the meaning of persist? What is the meaning of persist?
Reuse.
Repeat.
Making the RTD available in the RAM. Making the RTD available in the RAM. Even though the next RTD computed finished. Even though the next RTD computation is finished also, don't remove this particular RTD from the RAM. The RTD whose output is commonly used by multiple flows, that RTD we will persist generally. Many questions they ask. Generally, which RTD you will persist means you won't. If you persist R2, there is no use. If you are persist R2, nothing. No flow is using this. Only one flow is using this R2 output. If I persist it, you won't get any. If you persist R4 means three different flows are using its output, right? So persist R4, the RTD whose output is used by multiple flows, that RTD you persist it, so that it is going to give the output, means providing the output to multiple flows. What is persisting means making the RTD available in the RAM, even though the next means if you take the flow one, once R4 execution finished, next R7 you get. When R7 execution finished, R4 still available in the RAM, right? Hello.
Yes.
Once
Yes,
R7
it is
execution is
persistent.
finished, still R4 available. Once R8 execution, R7 gets removed. R8 also. Now, once the output is collected, now which RTD in the RAM?
R4.
R4.
R4 available in the RAM, right? Because R4 is persisted. You made R4 to persist. Okay, available in the RAM itself. R4 is removed. Whenever you trigger the next flow, the flow execution will be from R4 to R6. These many steps decrease, right? Because R4 output you will collect, R4 is ready to give the output, R5 and R6. This is your flow, R5 and R6. R4 already there in the RAM, right? No need to again re-execute, already R4 is there, directly R5 and R6. Here also, directly R9 and R10, taking R4 output, already R4 available in the RAM, right? R4 already available. So your flow will be R9 and R10. Understood the advantage of persistence, right? Hello?
Yes.
Yes, sir.
So I have one question here. So instead of persisting whole RDD, why can't we just persist the result set? Because ultimately we are interested in the result set, right? Is it something not possible?
So R3 itself, R3 is nothing but the result set, right? The data output.
Oh, but you are processing the data to get some meaningful result set, right? So for example, R1, R2, R3 are there.
That R3, okay. Okay. R3 is there. Once, what do you mean by R3 dot per R4 dot persist? R4 dot persist. R4 dot persist, right? Yes.
So when you say R4 dot persist, when you process R4, right, it will give you some output. That output will act as input to R5, correct? My question is, ultimately we are interested only in the output of R4.
R4 dot persist means the output R4
Output
dot
of
persist.
R4 is persisted.
R4 output of R4 is persisted.
Not the complete data set, right? So
One second.
but-
One
so
second.
my
Right? One second. I'll make it clear. I've got only R1.
Mhm.
I got very simple answer, right? For you, whatever you asked. Only R1 available initially. All R2, R3, R4, they are not available. From R1 only R2 gets generated. On R1, whatever transformation you apply, the result, whatever is nothing R2.
Okay, okay. I got
R2 dot transformation, whatever you apply, that is R3.
it. Okay, I got it. Yeah.
Okay. Only R1, initially R1 available with some data, huge data. And from R1 only R2, from R2 only R3, R3 to R4. That is whatever steps you are following, right? Transformations, merging, filtering, grouping, or whatever you do on the data, that the next one is the output. On R1, if you're performing transformation, you got R2. Again on R2, you perform some R3. Again on R3, you perform some transformation, you got R4. Transformation on RTD, the results of an RTD is also an RTD. If you perform any transformation on RTD, the resultant is an RTD. R4 dot transformation, right? You got R. Understood right now?
Right, I got it. Yeah.
Fine.
Thank you.
Okay, that's fine.
And Vijay, one quick question. So simple. So is PySpark is the platform independent? I mean, platform independent in the sense, will it be, I mean, use on Windows as well as the Linux machines? Only it is, we have to use only one.
Yes, I'll show you how to install PySpark on that Windows Linux service.
I mean, yeah, we
It
can
can-
use
it
on
can-
any of the operating system in that case.
Yes,
Simple.
yes.
Okay, fine.
Fine. Yesterday, as I was discussing, right? Yeah, PySpark features. Main feature of PySpark, in-memory computation, which you are not able to see in Hadoop, right?
Yes.
Lazy evaluated. Lazy evaluated means the flow on demand only will execute the flow. And one more persistence feature also not available. This is missing in, right? Already executed transformation. No, in Hadoop compulsory, you need to re-execute. Means
In a
every
sense, map reduce.
means
Yours.
without mapper, reducer can't be executed. Compulsory always you need to execute mapper. Means internally in Hadoop, whatever you perform, right? Every time you need to come from that, it should re-execute from the start. For example, generally you're not able to see that what is going on in map reducer, right?
Yeah.
Internally, the transformations happens at the mapper level and aggregations happens at the reducer level.
Reducer level, correct.
So mapper is going to, for example, the same task if I take, mapper extracted the salary and the reducer is computing that max sal and min sal, right?
Correct.
Second time, if you performing the task, right, for already you performed for total salary finished. Second task is some max salary you are performing. You cannot omit mapper directly. You cannot execute the reducer. You cannot means avoiding that mapper is not possible. I'm saying already. Okay.
Yeah.
We
On top
need
of
to
MR
do
only,
it.
we are.
If we talk about this map reduce, we say in Hadoop, map reduce. Mapper is there, reducer is there. Internally, mapper and reducer are the two things, right?
Yeah, components.
These are the two components. This mapper output, always the mapper output is taken as input by the reducer.
Reducer, correct.
Mapper, okay, for example, it extracted the salary, assume.
Yeah.
And reducer performed the total salary. Yes. Aggregation. This
Yes.
first example, already salary extracted, right, for first time. And now the second time directly take the salary and execute the reducer only, don't execute the mapper. Can I say in that way?
Yeah.
Reducer is optional, but mapper is compulsory in map reduce execution. In any execution, right? Mapper is compulsory.
Compulsory, yeah.
Reducer is optional. If you only for aggregation is there, then only reducer. Simply saying some kind of aggregation for some tasks only this. But mapper is mandatory for all the execution tasks.
Yes.
I said, right, in Hadoop, in the initial classes of Hadoop, I said number of tasks in Hadoop always depends on number of blocks. Can you remember? Number of tasks always depends on number of, if data is divided into 4 blocks, 4 tasks. Into 10 blocks, 10 tasks. What are these tasks? Mapper tasks. What are these tasks? Means mapper tasks.
Yeah.
So number of tasks always. So here, what I mean to say, compulsory mapper should execute always. For the second task also, again you perform that everything and extract salary, again you perform this max salary. Again, tomorrow, if you want to perform some min salary of the particular department, sales department, I want to know which is the min salary given. Again, you re-execute this mapper, extract the salary, that output you take it as reducer, again execute. But directly, already yesterday I computed salary, take that output and reduce it. No, not, you cannot do it. Already executed transformation results, you cannot take and you cannot compute in only the reducer. No. In Spark, you can do it. That is persistence feature is called. Again, in this persistence, you got different options, persistence in the memory level, in the RAM level, in the disk level. Right? So multiple options are there in this persistence. I'll be discussing one by one. And one the lazy evaluated means on demand executing the flow. Immediately on defining, don't execute. Once I make any action, whenever I make any action, then only execute the entire flow, right? And one more is fault tolerant, immutability, and partitioning. See, from R1, R2 is getting created. Do you think R1 got modified?
No.
See, just now I said, right?
R1 is as is.
R1, see, R1, you are applying transformation, you got R2.
R2 only. Yeah.
On R2, you apply transformation, you got R3.
R3.
Means on R1, you applied some transformation, like anything, filtering or map transformation or merging, something transformation you applied. Do you think R1 got transformed or modified?
No, R1 is
No.
as is. That's the main raw data.
R1 will be immutable. Immutable. Immutable means changes, modifications are not applied.
Not applied.
You cannot change, you cannot modify them. The original R1 will be there. Just R1 output is taken, it is transformed, stored in R2. R1 has got 10 lakh records, means R1 will be having 10 lakhs only. The 10 on that you apply transformation. A new R2 is created. Simple, right? Very X equal to 10. Simple example. I'm creating a Y from it. I'm creating Y from this. X plus 4 equal to Y. What is X value?
14.
What is X value? Do you
X is
think
called
is it
10 now?
being modified?
No.
Six.
X is always
X is
10.
10 only. X is 10 only. Y is what?
14.
14. So the X value add 4, that is what? Y value.
Correct.
Okay. To the X value, if you add 4, that is what? Y value. X value is 10 only. Here also the same thing. On R1, if you're performing some transformation, R2 you got. But still the original R1 is not modified. That is what? Immutability. Immutability. And partitioning, you know, right? They are divided into partitions stored across multiple RAMs.
Yes.
Right. Fault tolerance, there's a lot of discussion on this fault tolerance. You may ask.
Yeah.
Students
Redundancy.
you may ask, you are saying that your RT data object, that is RTD, divided into multiple partitions, and that partition stored across multiple worker nodes. What happens if a particular worker node is down, or two worker nodes are down? There is a, how it is going to means Spark has got powerful fault tolerant model. I said, right, it has got the feature resilience feature. It has got resilient distributed data sets. It has got the capability of regenerating the lost partitions for a particular worker node, and it can re-execute it. So in that, I'll be discussing multiple cases in this fault tolerance case, multiple cases, right? Case 1, case 2, case 3. If a particular persisted RTD machine is down, then what? If a normal machine is down, right? While collecting the output from R2 to R3, if R3 is down, then what happens? I'm collecting R3 is collecting output from R2. R3 machine collecting output from R2. During that collecting process, if the current R3 is down, then what happens? Okay, that is one. If from R2 to R3, R3 is collecting the output, but if R2 is down, I didn't collect the output. R3 didn't collect the output while collecting only R2 down. that machine is down, right? Then how? If already a persisted machine are making the RTD to be available in the RAM, that machine is down. If the persisted RTD machine is down, then what?
Gonna regenerate.
Yes, that's what all that multiple cases I'll be discussing. I'll go a lot of discussion on this. So first you need to understand the entire Spark execution model. So whatever later you implement by using Python or Scala or Java, means generally here my language is right Python. Spark with Python, right? PySpark. Yes. So PySpark means you have got separate Python API is there. Like Python has got many thousands of modules packages, right? So it has got a API PySpark, right? Okay, in that. So, but whatever that we have got the important functionality of Spark data frames concept is providing many functions to perform that various operations. You no need to write huge tasks. So depending upon that, the only thing is your time, where the time will be taken for as a data engineer, right? So if you are performing some kind of extracting process transforming, in this transforming only your most of your time is going to take. If data you want to bring the data into a particular format, there the time you are going to take the time, right? How you are going to transform it and next process it. Okay. So first you take the data. So different functions are there, inbuilt functions, but they won't, some will be expecting only key value pairs. So the data is, you got 10 columns, 10 fields are there. Employee ID, name, salary, department number, city, designation, 10 are there. But your function is expecting only key and value. You cannot take all those, right? In such case, you need to transform into key value format. The data has to be transformed into key value depending upon your business logic implementation, right? My task is, you're taken some sales data. My task is, I want to know city-wise what is the total revenue generated. To the either you got some lakhs and lakhs of records are there. From that, I want Hyderabad city, what is the total revenue generated? For Pune, what is the revenue generated? So what is the key and what is the value here? City will be the key, and that whatever that transaction prices, whatever that transaction price, if you got of 10 fields, if a sales, what is that? Product ID, product name, price, quantity, in that way, if you got only that what you are going to extract, the city and the price column. Only these two columns will extract as key and value. City as the key and price as the value, and you are after transforming the data into that form, right? Now you provide that to that function directly produces the results. So many formats what your functions are expecting, you need to bring the data into that and apply it on that and perform the transfer. So each and everything I'll be discussing in brief. You have got many functions. You can see that. One second. PySpark, need for PySpark session, PySpark context, RTD, PySpark RTD, parallelizing, repartitioning, broadcast variables, accumulators, PySpark RTD computation, RTD's computation. And in Spark, we follow DAG model, DAG, directed acyclic graph model, right? And RTD computation steps in that, and persistence features, options, and Spark core computation, fault tolerance model, and creating Spark objects, groupings, aggregations, list by key, group by key, and various actions, inbuilt transformations of this Spark one by one. And coming to this PySpark data frames, right? RTD with a schema we call as a data frame, right? With a structured, it's a data frames. We have got many things, right? Creating data frames with a select, collect with column. We have got many functions. Many functions are available, each and everything for performing these operations. PySpark SQL functions, aggregate functions, window functions, date and timestamp, JSON functions, built-in functions, when exp or lit split. In this way, built-in functions of PySpark. And PySpark external sources working with SQL statements, Spark integration with Hive, Spark and Hive integration, Spark and MySQL integration, working with CSV data, JS1 data, and remaining other different file formats, transformations, and narrow and wide transformations, adding columns, dropping columns, handling nulls, window function, writing back to external sources, deployment modes, local mode, cluster mode, PySpark applications, states and tasks, drivers and executor, building Spark applications, pipelines, deploying Spark cluster to and PySpark streaming concepts, PySpark integration with Kafka, and PySpark ML machine learning library. This is everything I'll be discussing in brief, right? Yes. Yes. Fine. So next, okay, we'll be continuing with this entire course. From the next Saturday, I'll be starting with this actual technicals of this PySpark. So still, if anyone have not enrolled, try to get enrolled for PySpark. Means people who are only attending PySpark directly, all right? So try to just enroll yourself. So the people who have already enrolled for the entire this PySpark and Hadoop, okay, it's fine. Next Saturday, you will get a new link, right? To your mails or yes, I'll be forwarding, means that online team will forward the new link to your mail IDs. Follow that new link. So just the others, right, who didn't enroll for this PySpark course, right, try to get enrolled for the PySpark course. So the link they'll be forwarding to your mail IDs. So follow that link from the same time at 5:30 p.m. So we'll see more discussion. I want the sessions to be more interactive, right? Yes. We'll discuss everything in brief, right? So point to point and clear notes, as I said, you'll be getting the videos, right? You'll be getting the videos to your drive. Fine. So any other queries you have got, anyone? Right.
Vijay, one small question. So do we have the block? I mean, in terms of storage, there is a block concept on Hadoop, right? So is it available on the Spark as well? To storing and to storing something on
Yeah, that everything I discussed in this RTD computation, right? How they are going to data objects, right?
Okay, fine.
Again, I need to discuss a lot of example for that. Fine.
Okay. Yeah.
Okay, fine. So next Saturday we will be discussing, right? Fine. Same 5:30. You can follow that. Next Saturday, a separate a WhatsApp group for PySpark, right? Yes. Fine. So I'm stopping for now. We'll continue next Saturday, right? Yes. Fine.
Thank you, sir.